Hello, everyone. Today we'll be doing question 4 for ratio tests for convergence review. If you have any questions about the actual ratio test itself, there will be a separate video for that. So let's dive into question 4. Determine the convergence or divergence for the following series. Series is the summation when n equals 1 to infinity for n to the power of n divided by n factorial. First things first, when we're doing the ratio test, we are finding the limit as n approaches infinity for the absolute value of a sub n plus 1 divided by a sub n. So it's important to identify our a sub n and our a sub n plus 1. A sub n is always just going to be our series, n to the power of n divided by n factorial. A sub n is different. We are substituting n plus 1 into anywhere we see an n. So in this case, a sub n plus 1 is n plus 1 to the power of n plus 1 divided by n plus 1 factorial. So now we're going to take the limit as n approaches infinity for the absolute value of a sub n plus 1 divided by a sub n. This here is when we substitute in our actual values for the series. Our next step is to our next step, we take the absolute values and we do not need them anymore because all of our quantities in this will be positive, so there's no need for them. We also can notice that we're multiplying here instead of dividing like we were before, and that's because we have a fraction divided by another fraction. And when we have that, our bottom fraction is you take the reciprocal and you multiply the other fraction by that reciprocal. So that's what you see there. And then after that, I do some expanding of the terms. So you can see that the n plus 1 to the n plus 1 power, I take that and I rewrite it as n plus 1 to the n power times n plus 1. I also rewrite n plus 1 factorial to be n plus 1 times n factorial. And thus we're able to simplify easier. So we have an n factorial here and an n factorial here. We have an n plus 1 here and we have an n plus 1 here. And thus we are able to rewrite this as the limit as n approaches infinity for n plus 1 divided by n, all to the power of n. And this here is a property. This series here approaches e. That's how you would approach e. And we know that e is greater than 1, thus the series diverges according to the ratio test.